So today, we're going to be doing the opposite of what we did yesterday. Yesterday, I gave you guys a graph of f, and from that you sketch f prime, f double prime. Today, we're going to start with f prime or f double prime and sketch the graph of f. Okay? So now, I thought it would be harder, but my 5th grade tells me it was easier. I don't know if that's because we've been laying a foundation for the past couple of days with this, or if maybe it really is just easier. I don't know. Hopefully it's easy for you guys too. Let's go ahead and begin. All right, I'm just gonna barrage you guys with examples. There's gonna be a few things where maybe you want to make a special note about it, but there's just gonna be a bunch of examples, okay? Because once again, I'm not teaching you new concepts. I'm just asking you to look at things in a new way. So, example 1. The first thing I want to look at is I want to look at a first derivative graph. And that first derivative graph is going to look like this. And my goal is I want to sketch f of x. I'm going to put a possible graph, and I'll explain why I say possible in a minute. Okay, so f prime represents what of f? It represents the slope of f. Now, what is f prime up here? It's -1. Is it ever different? It's constantly -1. That means my slope of f is always -1. So, can you guys sketch a line that has a slope of -1 all the time? Go ahead and do it on your paper there. And what kind of a function do we end up with there? A linear, right? So, now here's the thing. There's not just one answer to this, and I'll explain why in a minute. But my slope of -1 would be down 1 over 1, right? So that would look like this. So this is a possible graph of f. Now I say possible because I did something that maybe just seems natural and intuitive to you, but I started at the origin. Did I have to start there though? Couldn't I have started up here and went down 1 over 1 and done that as well? Yeah. Because that also has a slope of -1, and that derivative graph would look like that still, right? Now that actually takes us back to some old math. What is the equation of this line? -1. Now if I want to turn that into a y equals function instead, how do I turn a y prime into a y? Integrate it. Now if I integrate y prime, I get y. If I integrate -1, what do I get? -x plus c. And that plus c is a shift up and down. So do we know what plus c is in this case? No. So that plus c means it could be +2, it could be +4, it could be -5. We don't know where this linear line is. We just know that it is a linear function with a slope of -1. So when you're working backwards, you're actually working at a deficit of information. When you work forward, you have all your information. But when you work backwards, you lose information because you don't know your initial condition. Remember that word? Give you a point so you can find C. All right. Now I could change the story and I could say, well, f of 0 equals 2, and then you know that it has to have a y-intercept of 2, right? So there's that. So let's start you guys off with one of those easy ones there. I want you guys to, well, I kind of already gave you one. Maybe you want to try a different level of skill, or you want to try another one of those? All right, let's do another one. I think you guys can handle it. Let's do example 2. Okay. This is f prime. I want to get a graph of f out of that. Okay, so this is a graph of f prime, right? F prime is the what of f? The slope of f. So what do I know about the slope of f by looking at this f prime graph? Okay, how do you know it's a parabola? Good. Okay, good. So, where is f increasing at? Where does it have a positive slope, in other words? To the left of what? 1. So from here to here, my graph of f is increasing, right? Okay. And what's happening over here? Decreasing. So it goes from increasing to decreasing at 1. Is this concave up or down? Good. All right. I'm just throwing questions at you. Okay. Okay. Yeah. So it's a negative slope, right? So what do you call the slope of a slope? Concavity, right? And if it's negative, it's concave. So that's another way you can tell. I was thinking of just a picture myself where it's slope up, slope down. We're at the top of the mountain. That's a maximum, so it's a concave down, right? So we have increasing, right? And then we have decreasing. And I should be more specific here. I should say F is decreasing, and I should say F is increasing. In this lesson in particular, the word "it" is murder. So if you say, "Oh, it's a parabola because it's going up and then down," it's like, what are you talking about? Well, the proper way to say it is, since f prime goes from increasing to decreasing, therefore f must be a parabola. So you want to be clear with your language because we're talking about two different graphs. If you say the word "it's," it means nothing. So where is this max going to be on this graph here? At 1. So does it matter where I put it? No, because that's our C value, right? We don't know how far up it is. All I know is that to the left of 1, it's increasing, and that to the right of 1, it's decreasing, and we have our parabola. Okay? That's all that I know. No. Well, they could. I doubt it. If they did, it would have to be an FRQ, right? They could turn into multiple choice, match this graph with this derivative. But what we're really doing here is we're laying a foundation for some more abstract types of questions that they could ask you. Like they might say, this is the graph of f prime. What do you know about the concavity of graph f? So you have to go, okay, concavity is second derivative. This is first derivative. So second derivative is the derivative of f prime. So the derivative here is -1, therefore f has to be concave down, right? It's a lot of words, but that's what you have to do. So we're laying the foundation for some more abstract types of questions. All right, so student practice. You guys ready? Let's do you guys with a linear one. I'm going to start with an f prime graph here, and we're going to go like this, and we're going to say this is at -2. So you guys go ahead and see if you can sketch what that graph would look like. The graph of f. What would the graph of f look like? Jonathan, what can you tell me about f? Good. It's a parabola. Jillian, what more can you tell me about f? Okay, I agree. Heather, what more can you tell me about f? Like, that wasn't easy for me. I just stopped and think about it. Huh? Nothing else? Okay. I'm looking for more specifics. How about this? Let me ask you a more specific question. Will it have a min or a max? A min, good. And Eric, where will the min be located? Good, okay, so you guys have it. So I'll go ahead and analyze it here then. So we have to the left, it's, oh, I said it's. To the left, f prime is negative, which means that f is what? Decreasing. And to the right, f prime is positive, which means that f is increasing. Right? So if we go from decreasing to increasing, that makes it a minimum. Okay? So I have a minimum like maybe here-ish, decreasing to increasing. Okay? And I don't know if this is going to help. I showed this little chart to my 5th period. It may help you or it may not. But so you guys already know that a relative max is when you go from a positive f prime to a negative f prime, right? So it goes up and then down, which gives you a max, right? And you have a relative min whenever you go from a negative f prime to a positive f prime, because it goes down and then up, right? Now, but what does that look like on an f prime graph? We just saw it on the last 2 problems. If f prime goes from positive to negative, then it's like this, positive, negative. So you're going from a positive to a negative, so that makes this a max. Whenever it goes from a negative to a positive, negative to positive, that is a minimum. Okay, so there's that. I see some people writing it, so I'll wait. Yeah. So I think we're on example 3 now, right? Hey. This is an f prime graph. We want an f, right? So let me ask you guys this. So f prime is our what of f? Am I irritating you yet? So when I'm irritating, that means you've got it. That's good. So this is our slope of f. So can you guys tell me where the slope of f is positive? On what interval? Sure. So from 3 to positive infinity, that's a positive slope. Was it 4? Oh, I thought you said 3.
I said 3.
Oh, thank you. That's cool. Bye. All right. So, so he said it's from here to here. Do you guys think that that f is increasing from there to there? I disagree. I think f prime's increasing from there to there. Remember, f prime is the slope of f. F is increasing when f prime is positive. So can you guys tell me where f prime is positive? What were you saying, Heather? 0 to 1? Sure. That's positive, above the x-axis, right? So my slope is positive there, right? And where else is it positive? There you go. Where is the slope negative? Good. Right? So f is going to have f increases, right? F increases. Here, f decreases. Now, where are my minimums and maximums going to be? One and 4, right? When it goes from a positive slope to a negative slope or vice versa. But let's label these. Here I'm going from a what slope to a what slope? So I went from a positive slope to a negative. What will that make this point? That's going to be a max. It's an f max, right? Not an f prime max. It's an f max. Because on f prime, that's a root. right? What is this one going to be? That's an F min, right? It's a minimum on F. So can you guys trace this? So put your hands up on the left over here. And I want you guys to, we're going to constantly be moving it to the left. But as we do, I'm going to tell you what to do with your hand as you move it to the left. Ready? So go ahead and start moving and increase it. And now decrease it. And now increase it. Right? Increase, decrease, increase. Right? So it's going to go like this. It's going to go increase until I get to what number? And then it's going to reach a max there, and then it's going to start to decrease until I get to 4, and then it's going to start to increase. Okay. Oh, Christian's coming. Student from last year. I can't answer it. I'll have to call him back. So we have F prime. All right, you guys sketch F. Hello. Hey, Christian. That's okay. What's up? They won't. Okay, I'll call him. Oh, well, maybe if I call him, I'll try. Hey, Teresa, it's Russ. Hey, so Christian stopped by. He wants to know if he can come in. I'm okay with him coming in if you want him to. If that's okay with you, I don't know. Forms or something. Yeah, I didn't know he was coming. Yeah, I think he just popped in. Yeah. Oh yeah, I've never even seen him honestly. Okay. Well, no, I think he'll know that I'm teaching, so he'll probably just hang out after school. So. Okay. Okay. Thank you, Teresa. Bye. So you guys got any guesses out there for me? Let's see, where are we? Put these same numbers up here. All right, so I'm going to ask you, or you, would you come do it for me? Should we chant your name again? No. It's a little harder now with all the extra syllables. I kind of like the you. But, all right. All right, thank you. So what do you guys think? Yeah? What's wrong? No. No. The slope has to be 0 at 2, right? And the way she's drawing it, she does have a horizontal tangent line there. So she's good. Can I show you guys something interesting? What is the slope of the slope right here? And what do we call the slope of the slope? F double prime, right? And when F double prime is 0, it's a what? Point of inflection. Now look at F. You guys see how it's switching concavity there? Okay, so, all right, let's continue onwards with our study there. I don't know how we're doing on time. I feel like we're a little behind. All right. Stop. All right. So I'm going to give you something special here that's different, right? You guys remember what that's called over there? Oh, look at you. Yes. I did. But you had to know what I'm talking about for it to make sense. So it's still good. All right, so we have an initial condition. But let's talk about the slope for now. Let's ignore the initial condition. What do I know about the slope of f? From negative infinity to 1, it's a positive slope, so it's going up. And what's more is this is always 2. So what kind of a graph would that be when it's a constant slope? It's a linear, so we've got a straight line, right? And then we also have what down here? Another straight line. That's what? So it's a straight line up and a straight line down, and the graph exists at 1 equals 3. Now there's different ways to draw this, but what kind of graph am I going for here? Obviously, yeah. So at 1, we're gonna have 1, 3, right? So I got to put that dot there. 1, 3. That's my initial condition. Now, to the left of that, it has to have a slope of positive 2. So something like that. And to the right of that, it's going to have a negative 2. Okay? Now, that's not the only way I could have drawn that graph. I could have done something kind of weird and strange, but that's because we're working backwards. Like I said, you lose information when you work backwards. There's nothing wrong with me doing that. I still have my initial condition, and I still have slopes on either side, right? So we don't know. Did they really connect or not? We don't know. But I'm just making it fit what we're used to seeing. Okay? All right, so there's that. Yeah. Because I gave you this initial condition. Yeah, I told you that dot has to be on F. So, all right, let's do another one. You guys see if you can do it. If I were to leave the one on the left kind of the same, like we said yesterday, and then flip the one on the right, we would get that derivative, right? So that's good. So asymptotes, absolute values, weird things could happen. We've got the main meat of that out of the way, I think. Now I'm going to switch gears a little bit. We're going to talk about giving you guys an F prime graph. I don't know what example I should have been on. I haven't been writing it. What should I put here? 6? All right, so now I'm going to give you guys an F double prime graph. And what does F double prime tell us about F? It tells us the concavity, okay? So what do we know about F double prime here? It's what? Negative. It's negative 2. So since F double prime is, when is it negative? Always. Since F double prime is always negative, F is always concave down. So, what kind of a shape would always be concave down? A parabola, right? There we go. That's the best we're going to do. We don't know anything about where it's located. We don't have any idea about how wide it is. We just know it's got to be an upside down parabola-ish shape. Okay. Okay. All right. So F double prime represents the what of F? Concavity. Where is F concave down? From negative infinity to 3. Because for that whole half of my graph, F double prime is negative, which means that F is concave down, right? And then for the other half of my graph, F double prime is positive, which means that F is what? And therefore, what do we call that root of F double prime? So point of inflection. See if you guys can sketch one. It's got to be concave down everywhere to the left of negative 3, and then it's got to be concave up to the right of negative 3. Oh, positive. So we have concave down looks like this. All right. And they switch at what value? 3. So 1, 2, 3. Let's see if Jacob can show us the graph. Good. I agree. Thank you. That's all right. What did you do down here or something? Like this?
Nope.
What did you do? Want to show me? We lose all kinds of initial conditions. So, you don't know exactly. So long as it fits the information we do have, we're good. Oh, yeah, that works. Hello? Hello again, Christian. Well, let's keep the game up here. Got 2 more I want to do with you. No, that's too hard. All right, you guys draw for me the graph of F. Yes.
These.
What do you mean?
Wait,